will discuss how to find the conditional mean and conditional variance. We have already discussed how to find what is the conditional probability mass function in case of discrete case and conditional probability density function in case of continuous cases or continuous random variables. Let us discuss first for the discrete random variables. So let xy be a discrete bivariate random variable with joint probability mass function pxy of xi yj and the marginal probability mass function of x is px of xi and the marginal probability mass function of y is py of yj. So let xy be a discrete bivariate random variable with the joint probability mass function is px of xi yj, the marginal probability mass function of x is px of xi and the marginal probability mass function of y is py of yj with some I maybe is equal to 1 to, if it is finite range then it will be 1 to some n, and j is also, if it is finite then 1 to some m, otherwise it may be countably infinite. So we know that the conditional probability mass function of yj of y, mass function of y given x is equal to some particular value xi in the domain, the conditional probability mass function given x equal to xi is defined as py given x yj given xi. So for any values of yj in the range and particular values of xi, this is defined as pxy of xi yj by py of yj, sorry, xi, px of xi, because it is y given x, this is. So we assume here that p of xi should be not equal to 0, that's why xi should be range of x. In that case only px of xi not equal to 0, otherwise it will be 0. So this is the conditional probability mass function. The conditional mean of y given x is equal to xi is defined as, so here the notation it is followed. So conditional mean, so given that x equal to xi, the conditional mean or conditional expectation we can say of y given that x equal to xi is defined by mu y given xi. So it is defined as mu, it is the notation y given xi, some value. So this is nothing but summation of yj, all the values of yj multiplied by probability, conditional probability mass function y, yj given xi, x equal to xi. So here this yj given xi we can find from here, and then we can say sum. So you can simplify, or you can just more precisely we can write like pxy xi yj by p of y yj. So this is the definition actually, whatever convenient. We can find out first what will be the conditional probability mass function, and then we can find out. So then what will be the variance? So for variance, like here you can see that variance of sigma square y given xi is variance of y given xi. So this is expected values of y minus mu of y given xi whole square given xi. So this will be this formula, but it can be reduced like earlier. It can be like in this simplified form also we can represent. So let us write down here. So the conditional, first of all, conditional variance the conditional variance of y given y is equal to x is equal to xi is defined as, so it is variance of sigma square y given xi, or we can say variance of y given xi. It is expected values of y minus mu of y given xi, this is we have already defined, whole square. So it can be represented as summation of all the possible values of yj minus mu of y given xi whole square multiplied by probability conditional probability mass function yj given xi. So it can be simplified as expected values of y square given xi minus expected values of y given xi whole square. So let us, we did not define notation, so this notation is, it can be represented as expected values of y given xi. So this is the notation. And what is expected values of y square given xi? So the where expected values of y square given xi, this is nothing but summation of all the values of yj over the yj square y probability y given x conditional probability mass function y given x yj given xi. So this is the variance for conditional variance of y given x equal to xi. So basically this conditional mean and conditional variance, it will be, if we consider the random variable, this probability mass function as the conditional probability mass function, with respect to that, if you find the mean and variance in usual mean and variance formula, you apply, then you will get this conditional mean and conditional variance. So now you can ask that the opposite, how we can similarly we can define the conditional mean and variance. The conditional mean of x given that y is equal to yj, suppose you want to find, so then you have to just replace x by y and y by x. So you have to just you have to change the position of x and y. So then you can find that. So just I am writing again, the conditional mean of x given y equal to y yj is defined by, so it is nothing but expected values of x given yj. So it is mu of x given yj. It is nothing but summation of all the possible values of xi with respect to the conditional probability mass function x given yj xi given yj. So now the variance, the conditional variance, the conditional variance of x given that given y is equal to yj is defined by, so this variance we can write sigma square of y. So here actually conditional mean of x given yj we are taking, so x, it will be sigma conditional variance of x given yj. So this is defined by expected values of x minus mu of x given yj whole square, this expected value, and we can write summation form all xi, sum of all the possible values of xi minus mu x given yj into conditional probability mass function x given y xi given yj. So just I have written here, you can check, it is very similar to this expression. Just here I have written this expression, or we can again write this, because due to space I have to compromise. So this is equal to, we can write summation of all possible values of xi minus mu of x given yj whole square multiplied by the conditional probability mass function x given y xi given yj. So note that this yj fixed here. Similarly in the previous cases xi fixed. So here given a yj, that's why yj fixed, some value yj, possible value in the range. This is the definition. it can be simplified as, because for computation it will be little complicated to compute whenever some numerical example whenever we will do, it will be not straightforward, it will be little computationally extensive. So that's why we will use this formula, simplified formula, that we have already shown that how it is coming for the general random variable cases. So here for conditional probability mass function cases also it will be followed similarly. So it is nothing but the second order raw moment y square, here actually x, actually it is a second order raw moment x square given yj minus expected value of x given yj whole square. So expected value of x given yj already we denoted here, x given yj, this is the expression yj. So what will be the notation is, so this is where expected values of x square given yj, this will be nothing but, by definition, this will be summation of all possible values xi square, all possible values xi, into probability mass function, conditional probability mass function, x given y, xi given yj. So hope you have understood it, this how it is coming. Now for more clarification, to clearly understand it, we need to do some numerical example. Let us do one numerical example. So before going to the continuous cases, let us complete it by discussing one numerical example. So here it is given, the joint probability mass function of a bivariate random variable xy is given by p of xy of xi yj is k into 2xi plus yj. So this example we have already studied. So here we are repeating because we want to do some more problems, so like related to compute the conditional mean and conditional variances. So I can remember that all this problem already we have done. So you can go back and you can check. We will do here also. It may be repeated, but you will understand more clearly. So here this conditional probability mass function of x and y, it is given like this: pxy of xi yj, the sorry, not conditional, this is joint probability mass function. The joint probability mass function of xy is given by pxy of xi yj. So this is equal to pxy of xi yj equal to k into 2xi plus yj. So k into 2xi plus yj, whenever xi taking value 1 and 2 and yj taking this 1 and 2, this will be is equal to 0 otherwise, where k is a constant, where k is a constant. So we have to find the values of k. So these are the questions. Find the marginal probability mass function of x and y, or x and y are independent. So let us do those things. So to find the k, we need to use the properties of the joint probability mass function. Here k is a probability mass function always greater than equal to 0, hence k has to be greater than 0, and we will find the k by the other property. If we take the sum of the all possible values, so all possible values xi can take 1 and 2, and y can take also, yj can take value y can 2, and the value pxy of xi yj, this should be equal to 1, which implies k into summation of xi is equal to 1 to 2, yj is equal to 1 to 2, k into 2xy plus yj, this should be equal to 1. Now we will write k into 2xy plus 1j, so we have to just 2 into 1 plus 1 plus 2 into 1 plus 2 plus 2 into 2 plus 1 plus 2 into 2 plus 2. This should be equal to 1, which implies k into, this is nothing but 3 plus 4 plus 5 plus 6, this is equal to 1. So this is implies 18k is equal to 1, which implies k is equal to 1 by 18. Hence our probability mass function we found, it is 1 by 18. So now if you want to find the marginal probability mass function of x and y, the probability mass function of x is given by px of xi for xi. Now by definition this is nothing but all the yj equal to 1 to pxy of xi yj, but it will be non-zero only xi 1 or 2 value, for otherwise this value will be 0. Px of xi is nothing but summation of xi of this value, this summation of y is equal to 1 to 2, this is 1 by 18 2xy. So what is the value? 2xy plus yj, 2xy plus yj. So this is nothing but this is 1 by 18 into 2xy plus 1 plus 2xy plus 2, this is nothing but 4xy plus 3 by 18. So this is the probability mass function of xi. So we can write properly, marginal probability mass function is given by px of xi, this is nothing but x is equal to xi, which is equal to 4xy plus 3 by 18. Whenever xi can be 1 or 2, this will be 0 otherwise. So you can see that, check that whether it is correct, this mass function, because if you take the sum of xi 1 and 2, 1 this is 7, 2 11 plus 7 18. So this will be, it is a probability mass function. Now next we will find the probability mass function. The marginal probability mass function of y is given by, because those values will be required, we long back we did it, so you can recall that, or again we have to find it, otherwise we don't have this function. For conditional probability mass function, we have to find for conditional mean and conditional variance as per the formula. We have to first find the conditional probability mass function. So now marginal probability mass function of y is given by probability of yj, probability of y is equal to yj, this is summation of xi pxy of xi yj. Now whenever yj is for yj is 1 or 2, then only this is non-zero, p of yj, otherwise this value will be 0, y is equal to yj, this is summation of xi pxy of xi yj is nothing but 1 by 18, 1 by 18, what is the joint probability mass function? 2xy plus 1 by 18 2xy plus yj, 2xy plus yj. Now fixing yj, whatever the value, xi can take value 1 and 2, 1 and 2. So we'll evaluate now 1 by 18, xy is 1, then 2 into 1 plus yj, and then next xi is 2, then 2 into 2 plus 1, sorry yj, this is yj is fixed some value. So then this is 2 into 2 4 plus 2 6, so this is 6 plus yj by 18. So finally what do we get? The marginal probability mass function p of yj is defined by probability of y equal to yj, this is nothing but 6 plus yj by 18. Whenever yj can take the value 1 or 2, this will be 0 otherwise, this will be 0 otherwise. So now you can check whether, because yj equal to 1, then 6 plus 1 7, xy equal to 2 8, 6 plus 2 8, oh yj plus yj 2 yj, sorry, this is 2 yj. So then we can simplify it by so 3 plus yj by 9. So this is the, so 3 plus yj by 9, actually I did a mistake, it will be 2 yj, so this will be 3 plus yj, that's why I just check it, because if it is a probability mass function, if you take the sum of yj, then this will be is equal to 1. So just I am checking yj equal to 1, then 3 plus 1 4, and then next yj equal to 2, then this is 3 plus 2 5, so 5 plus 4 9, so it will be, so actually 3 plus yj by 9, so 9 plus by 9, this will be 1. So this is correctly mentioned. So this is the marginal probability mass function of yj. Now are x and y independent? So if x and y are independent, if x and y are independent, then pxy of xi yj should be equal to px of xi into p of yj, for all xi and yj values. It should be true. So by looking this, it is not clear. Suppose let us take some of the values. Let us consider, suppose xi is equal to 1, y is equal to 1. So what is pxy of 1 1? Pxy of 1 1 is 1 by 18, 2xy plus yj. 2xy plus yj is 2 into 1 plus 1. So it is 2 into 1 plus 1. So 3 by 18. So this is nothing but 3 by 18. 6. 3 by 6. Now whatever px of 1, px of 1 is, where it is defined, px of 1 is 4 into 1 plus 3 by 18. 4 into 1 plus 3 by 18. So this is nothing but 7 by 18. And py of 1, what is the value? So py of 1 is here 3 plus yj by 9. So 3 plus yj is 1 by 9. So this is 4 by 9. So if pxy of 1 1, it has to be 1 by 6. This has to be equal to 7 by 18 for independence into 4 by 9. So this is equal to px of 1 and into py of 1. So note that it cannot be equal to, because in the left hand side this factor 7 not present. In the right hand side, or you can just directly compute what is the value it is coming, whether it is equal to 1 by 6 or not. But without computation also we can see that right hand side there, after cancellation also you cannot, there is a 7, factor 7. So but in the left hand side you cannot find any factor 7. So it cannot be equal. Hence x and y are not independent random variables. So x and y cannot be independent random variables. So are not independent random variables. So this is the third questions. It is are x and y are independent. It is they are not independent. Compute the conditional mean and conditional variance of y given xi is equal to 2. So how we can find the conditional mean and conditional variance? So for conditional mean and conditional variance, so we have already shown some of the formulas. For this we need conditional probability mass function. So what are the conditional probability mass function? How can find? So find the conditional, compute the conditional mean, conditional variance of y given x. It is asking only y given x. So we need conditional probability mass function of y given x. So the conditional probability mass function, the conditional probability mass function of y given x is equal to xi. Suppose the conditional probability mass function of y given x is equal to xi is given by, so or just write is, so by definition y given x, yj given xi. So particular values of xi, yj given xi we have to find. By definition it is nothing but joint probability mass function xi yj by the marginal x of xi. So now whenever if xi, whatever fix it is equal to 1 or 2, or xi belongs to 1 and 2, only we can find the conditional probability mass function. It is non-zero actually, and yj also can be take the value yj belongs to 1 and 2. So yj it is varying and xi some fixed values we are finding it. P of y given x, yj given xi. So if this is inside this this value, then only this joint probability mass function also non-zero, otherwise this is 0. So this joint probability mass function is 1 by 18 2xi plus yj. So this is 1 by 18 2xi plus yj by px of xi. Px of xi we computed somewhere here, 4xy plus 3 by 18. 4xy plus 3 by 18. So then this is cancelled, then we are getting, this is we are getting 2xy plus 3, sorry, 2xy plus yj by 4xy plus 3. 4xy plus 3. So let us whether it is correct. 4xy plus 3 by 18. So then we write because this is so hence. So let us write next page. Hence the joint probability mass function, hence the conditional probability mass function of y given x equal to xi is, so what we found, y given x, yj given xi, this is nothing, this is equal to 2xy plus yj by 4xy plus 3 whenever yj is 1 and 2 and some particular values xi belongs to 1, 2. This is equal to 0 for any other cases. Now here it is asked, you have to find the conditional mean. This is the question. Compute the conditional mean and conditional variance of y given xi is equal to 2. So that's why we will put particular value xi here given xi. So hence the conditional probability mass function of y given xi is equal to x is equal to 2, xi is here 2, is given by p of y given x, yj given xi is 2. This is, we will put 2 here, xi 2, so 2 plus 2 yj plus 4, 2 into 2 4 by, so I hope you understood, or I just computing in mind, 2 plus 2 xi you have to put 2 here in this final form, yj by 4 into 2 plus 3. Whenever here xi already given, yj is 1 and 2, this is 0 otherwise. So finally we will get, this is, if we simplify it, yj plus 4 by, this is 4 plus 4 into 8, 8 plus 3, 8, 11. 11 whenever yj is equal to 1 and 2, this will be 0 otherwise. So now in this example, now it is very clear that this given condition given, it seems like this, whenever generally we are defining the conditional probability mass function, it seems it is a bivariate type. No, it is actually a variable is yj here and xi here as a act as a parameter or some constant value it is taking, and then this become a probability mass function. Here you can see that whenever xi become 2, it is just a variable is yj only here. So this is a probability mass function of yj and given to conditional probability mass function. So you can vary xi here also, but it is a probability mass function of yj given xi. So now it will be a probability mass function. You have to check it is correct, because if you take the sum of all yj here, y given x xi, so y is equal to 1, this value is nothing but 4 plus 1, 5 by 11, y is equal to 2, this is 4 plus 2, 6 by 11, 5 by 11 plus 6 by 11, 11 by 11 equal to 1. So this computation correct. Now we will use the formula now. What is the mean and variance? So it is asked in this question, find the compute the conditional mean and conditional variance of y given xi is equal to 2. So what will be the conditional mean now? By definition, now we found the